Welcome to the Accenture Innovation Center in Essen. Today we would like to walk you through our 5G campus network, which we set up here in the Zeche Zollverein. We will not focus on the background technology, so frequencies, how does 5G really work. We will focus on how did we set it up here, what is the network, what are the devices that we are connecting it with, and we will also give you a short overview of the use cases implemented here. We started in 2020 to set up 5G here in the Essen Innovation Center. We thought that this is really a perfect location to test this because we are surrounded by millions of tons of steel, concrete. We have a very industrial surrounding. The Zeche Zollverein these days is a UNESCO World Heritage, so you can test all of this here in a very safe environment. So it's basically like an industrial park that we can use for all these tests. The Essen Innovation Center already has a couple of other technologies that we use for industrial connectivity, for example, Wi-Fi, also the version Wi-Fi 6, the newest version. We use LoRa here, narrowband, and other communication technologies. And so we can compare the different usage scenarios here for connected workers or device connectivity in that environment with different technology. When we started to select partners for the implementation here of 5G, we wanted to use solutions that are available on the market or probably coming to the market very soon. We didn't want to have a theoretical exercise where we talk about 5G in a lab environment. So we looked at the market, even not sure yet what would be available. So because for all of the partners, all the telecommunications companies, equipment manufacturers, mobile phone providers, 5G is pretty new still. So we're speaking about beginning of 2020. Yeah? So this was still in its infancy. So there was not very many installations available yet. And so we were not really sure where we would end up. So how would it look like? It was more an open conversation we had with the different vendors to see, okay, what could work? What could we implement here, test here, so that it's also easily applicable to our clients and can be implemented there. So we gathered together the different requirements that we have and then tested them with the providers. So we invited telecommunications companies, here the typical big players here in Germany, and also we directly contacted some of the network providers that are available. We identified 4 main archetypes of how 5G could be set up here in Essen and in industrial sites in general. The first approach would be simply going to one of the carriers, buying a SIM card, and then using their public network with normal SIM cards, so everything going through the carrier network. The second option is establishing a so-called virtual network. So virtual campus network. So in this case, we are using still a public carrier, but we get a special segment in that network. So it's a bit separated from the rest, and all the traffic goes through our network in the end. This next option would be we take again a public network from one of the carriers and amend it with own infrastructure. So installing own repeaters or even better 5G antennas, for example, inside the building or in the areas of my campus where I don't have public coverage from one of the normal antennas. So it's basically amending the public network with my own network. And in Germany, the big carriers offer these mixed solutions. So it's a hybrid network. It's a combination of public infrastructure plus the local infrastructure that you run with them together on your premises. So in this case, if you are in an area where you don't have very good reception, you can basically build your own wireless network with 5G then on the campus and have better control on where you have reception or not. All of this, again, same thing. So going with the data-wise, it's still separated from the public network, and you would route all traffic going from the devices in the network through internet channels from your own systems, what is possible with that setup is you can also have directly a breakout point locally. So this means the data is not traveling through the back-end network of the carrier. It resides basically locally. So simply speaking, you have a direct shortcut from the base station, here the antenna, to your local network, which has a huge impact on latency, for example. And of course, it makes it possible that you don't have to go with all the traffic through the entire country, basically. Yeah. The fourth option is you are building a completely separated network. So this means you build your own base stations, you take your own antennas, the entire control systems, management tools and everything. You set up your own SIM cards. You register your own frequency area, which is possible in Germany. There's a special reserved frequency band that you can use for your own campus networks, which you can buy or license from the regulatory authorities. And then you have a completely independent network. So it's your 5G network, not connected with a carrier at all. So you have a control over it. And the entire software and the infrastructure is provided by one of the network equipment providers, like, for example, Nokia or Ericsson. Finding the right scenario depends on the use cases. So on a high level, we identified 3 main areas, but there are, of course, much more. The main scenario that we consider here from an Essen Innovation Center perspective, and also considering that we are very much focused on chemicals, oil and gas, utilities, so big production sites with lots of maintenance workers often working outside. For us, the most important one was how do we get mobile connectivity to the workers in the field? So in the production plant, inside the buildings, outside the buildings, how do they get high-speed network, reliable, secure, with mobile devices? So this was one of the, probably the most important use case we had. The other scenarios are sort of related to getting access, remotely access to high-speed computing. For example, with graphics acceleration to, for example, visualize 3D documentation of your plant. So what's happening here is all the calculations are happening, for example, in the cloud, and the only thing that's transmitted is the video image. And we've seen that this can be up to 16 megabits per user, just to show that. I've even seen, depending on technology, you have up to 70 megabits per user. So this all works fine, also with LTE and so on, but 5G is here interesting because you can have much more capacity in regards to bandwidth, so more people can use it in parallel. Also, latency is relevant for this because if you are accessing, for example, an engineering design tool, you don't want to have a big delay between when you're moving the mouse a bit upwards and when you see that happening on the screen. So that's a bit of a latency thing. The third scenario would be autonomous vehicles or devices. So the big things that always mentioned are drones or cars that drive autonomously. However, the assumption is there's no logic in the devices. So the entire logic, the compute power would be, for example, in local servers that would then remote control the device, the vehicle. And that requires extremely low latency. There, it's very relevant that you have a direct connectivity as fast as possible, because any delay basically would cause potentially an accident because you need to react quickly. However, also for us, for Essen, we didn't think that this is really our core area that we wanted to focus on. Based on the considerations we had about the use cases, we decided to focus on 2 technologies for 5G. Accenture chose to implement a virtual campus network in Essen. So taking the public network of one of the providers in Germany. So in our case, it was Deutsche Telekom. And our colleagues in Garching implemented a completely independent local network in their innovation center, and using, in this case, the technology of Nokia. So Nokia providing all the antennas and the backend technology, and Accenture implementing the whole network on site. The rationale behind this is that the Essen Innovation Center is very much focused on process industry, utilities, chemicals, oil and gas. And our focus thus is more on worker connectivity, so that we can give access to the workers in the field. And so outdoor coverage is for us more important. And for cost reasons, the virtual network is very, very attractive. For Garching, the focus is more on vehicles, for example. This whole area around remote-controlled devices, vehicles, is really very much a research area there, where there are proof-of-concept systems or production systems shown. And in this case, they focused on the completely independent network with Nokia, because this allows them to have a very resilient, high-speed, low-latency network on site, where all the devices can directly communicate with the local network without going through a public carrier. But now let us walk you through the devices used for 5G and the network and how the entire integration between the different components work. There's still not very many mobile devices available that support 5G. So we have a few examples here. For example, the new iPhone with 5G. We have the Samsung S20, which is also one of the first 5G mobile phones. And then a couple of Huawei devices that also support that. There are new devices coming out every day. However, the good thing about the network that we've set up here in Essen with the usage of the public network of Deutsche Telekom is we are not restricted to 5G. So we can support here 4G and even 3G. So even older devices can directly connect to our campus network. But of course, the bandwidth improvements and the high capacity only applies then in the end to the 5G devices. There is not so many wearable devices yet available for 5G. So we have, for example, the RealWear helmet, or we have a Microsoft HoloLens. However, both currently have no adapters or modems for 5G yet. So in the case of the RealWear, we are using 4G, but it's connected to our campus network. Also, there are currently not so many industrial routers for 5G available yet. We have one prototype here, which is a combination of a 5G router, IoT aggregator, so it can connect to local IoT devices. And by the way, it's also a Wi-Fi access point. So it can be, for example, used if you have a project office somewhere in the field, you put this device there, and you can connect your entire project team there and even use it as a Wi-Fi access point. Or it could be used on a campus, for example, in your production plant, to connect the last mile. If you don't have a cable connection, for example, to the production location, you could use this to bridge the gap between your in-building network and your backend. Or sometimes also use it as a backup for your network connectivity. There's more devices like this coming out every day. But it's at the moment, when we shoot here the video, still a very small market where we have only a few devices available. So how do you connect now devices like this RealWear or a mobile device to our campus network? It's actually quite simple. So through the portal of Deutsche Telekom, you order SIM cards. These are special SIM cards for our network. And they come in different form factors, and we simply install these SIM cards then in the mobile device. Unfortunately, at the moment, the campus network doesn't support eSIMs, so it has to be really the traditional normal SIM. But I guess this will be coming soon. You then activate the SIMs through the M2M portal that manages all the SIM cards. You can assign them with a certain profile to which APN they have access. So, and exactly this APN is the way how you can identify to which network the devices have to connect. So the APN is like in the normal network, like a VLAN. So it is a segregated network from the normal public 5G or 4G network of the carrier, of Deutsche Telekom. So we enter the APN on the mobile phone, and then it knows that it has to log in into that APN in the Deutsche Telekom network. In the M2M portal, I can order SIM cards, and when I have received them, I can configure them. So I can set them up where they belong to. I can see how much data was transferred over that SIM card, what's the current status of it. I could assign which APN should be used, so which network should be used. I can see events, potential issues, and some statistics about the usage. If we would have a hybrid network with local on-premise infrastructure or a completely independent network, we would use a solution like Ericsson Industry Connect. The portal allows me to manage the different elements of my network. I can create APNs, and I can then also monitor the devices connected to my network. I can see events, warnings about potential issues and who has logged in. The Ericsson Industry Connect portal allows me to create SIM cards. I just simply write the information with a small writing device onto the SIM card, and then I basically can configure them and program them directly locally on my own. We are using the public 5G network of Deutsche Telekom. So we don't use a small 5G antenna dot like this one from Ericsson. We use the public infrastructure here in the Zollverein. The base station is about 1 kilometer or 1.5 kilometers away from our office. It is currently still on 4G antennas. So when you're saying that we're using a 5G network, we currently mean that it's a 5G protocol that we're using. So all the communication from the mobile devices is going through 5G. If they are not supporting 5G, we can still use 4G or even 3G because it's all downward compatible. And the campus network that we have here from Deutsche Telekom allows all these different protocols. The antennas at the moment still work on a 4G spectrum. And therefore, we don't have, at the moment, the full capacity available and bandwidth. And also, we don't know yet 100% how it will work with the steel structures that we have here. So that's still an open point. We still have all the benefits of the entire enclosed campus network, but it is not yet on the full 5G spectrum and the 5G capabilities. So you could ask yourself, what's the benefit of having a campus network compared to buying a SIM card simply from the telecom store? The answer is, besides the isolated network, so that we have a separated virtual network within the public network of Deutsche Telekom, where we can control all the endpoints and see what's going on and see the communication between the devices, we also have a minimum bandwidth. So Zollverein is a tourist site, so usually in normal times there's up to 1.5 million tourists coming here. Even if they all upload video streams from all the sites that can be seen here simultaneously, we would still have at least 10% of the gross capacity of the antenna reserved for us. So this means we can have a minimum service level of data capacity that we can use for all the base services. If the capacity is not used, we can of course have up to 100% of the capacity. So how is then the data flow from the Deutsche Telekom APN, so our virtual network within the public network of Deutsche Telekom, to our internal company network? We have set up a VPN gateway on our side in Amazon AWS. This is connected with the Deutsche Telekom network. The data is flowing through the VPN gateway, and we have a so-called transit gateway behind it that decides then where to go within our cloud environment, or if we want to transfer the data to the internet. This is an example where we put a simple website on an AWS server to measure the bandwidth and the latency for the data communication between the local devices in Essen and the AWS cloud. However, there's not so many applications that usually need such a low latency. So for most use cases, this is fine. Also for video conferencing and so on. In the AWS cloud, we also host the central internet gateway. In our case, we simply choose a virtual Fortinet firewall with all the typical settings. And we can here control whatever traffic is going from our 5G network to the internet, and vice versa. Since it's a completely transparent network where we have full end-to-end routing, theoretically, we could also expose elements in our 5G network to the internet. But of course, that's another question then.